Welcome to the Deep Dive. Today, we're embarking on a journey into one of the most genuinely mind-bending ideas I've come across recently. It's reshaping how we might understand, well, everything. We're plunging headfirst into a concept called coherence physics. Now, even if you're deeply familiar with quantum mechanics or cosmology, you might want to buckle up.
Right.
Because this theory, it isn't just tweaking an existing model. It feels like an entirely new operating manual for reality itself.
That's a good way to put it.
It's aiming to unify everything.
Yeah.
I mean, everything from the tiniest fundamental particles right up to the vastness of the universe consciousness, even the bedrock of mathematics.
It's incredibly ambitious.
Totally. We're talking a complete reframing, replacing assumptions physics has held for, well, a very long time with something profoundly different, but also strangely elegant.
It has a certain internal logic, definitely.
So our mission today is basically to bring some clear order, some organization to this huge framework, make its intricate details understandable, hopefully even exciting. Let's unpack this.
Okay. And what's truly foundational here, maybe the best place to start, is that coherence physics says coherence itself is the primary operator of reality.
The primary operator.
Think about that. It suggests all physical reality, everything you see, touch, measure, it doesn't just exist, it dynamically emerges from what the theory calls a primary coherent state.
Emerges from it.
Yeah. So it's not just about understanding the universe we see, it's about seeing it as being built from this completely different, deeply structured foundation. Everything we observe is like a dynamic expression, or maybe more accurately, a dynamic reduction of this underlying universal coherence.
A reduction.
It's a shift from thinking about a universe of separate bits and pieces to one that's fundamentally woven together from the start.
Okay, to really get our heads around the sheer scope of coherence physics, we absolutely have to start at the bedrock, the core principles, right? The axioms that build this whole new vision. And the first one, the big one, is this idea that coherence isn't just a property of reality, it is the primary operator. So let's unpack that. What does that actually mean for coherence to be the OS?
Right.
It means that every single physical thing, every phenomenon, the light from a star, the way electrons dance at all, ultimately emerges from an active, self-referential, and structured primary coherent state.
Active and structured being key words there.
Right. It's not just some passive backdrop like a static quantum superposition waiting for something to poke it. No, this is described as a dynamic, fundamental field, always interacting with itself. You can maybe think of it as the universe's original, perfectly synchronized pulse.
Yeah.
Like an underlying harmony beneath everything. And its role.
Yeah.
It's profound. Coherence isn't just there, it's the source, the wellspring of all forces, fields, particles.
Exactly. And here's the really counterintuitive part, but also where the elegance comes in. It's not the presence of this perfect, unified coherence that creates our messy, complex, observable world. It's actually the reduction of it. The loss or the breakdown of that perfect coherence. That's what produces the universe as we know it, with all its different stuff and interactions.
Whoa, okay. So the breakdown creates reality.
Think of it like a symphony playing just one single, perfectly resonant note. That's the primary coherent state, high coherence.
Right, pure harmony.
Our universe, with its countless instruments playing all their different, often clashing melodies, that emerges when that perfect, unified resonance starts to, well, dissipate or differentiate.
That's a powerful image. Okay, so if this reduction of coherence is the engine driving everything, how does it actually happen? What are the mechanisms? How does reality bubble up from the superordered state?
Right. If we connect this to the bigger picture, this emergence relies on two really fundamental linked mechanisms: coherence selection and coherence reduction.
Selection and reduction,
Right.
got it.
Let's break them down. Coherence selection. This isn't random. Think of it as the universe having an inherent ability to, choose or stabilize a particular coherence condition.
Choose, like consciously.
Not consciously in the human sense, no. More like a dynamic preference. An active process where certain coherent states are favored or maintained or even amplified within a system. Like a spotlight picking out and solidifying a specific pattern of coherence from all the possibility.
Okay, so it picks a pattern, then what?
Then you get coherence reduction. And this, like we said, is the real engine of emergence. This is the actual transformation from that highly coherent unified state into states with lower symmetry.
Lower symmetry,
Yeah.
meaning more complex, more differentiated.
Exactly. And those lower symmetry states are what then show up as the quantum fields we know, the fundamental forces, all the matter and energy we see around us. This is literally how complexity and diversity and the specific rules of physics arise from something that started out much simpler and more unified.
So back to the orchestra analogy.
Right. So the perfectly harmonized orchestra, that single note, super high coherence.
Yep.
Coherent selection is like the orchestra deciding, okay, we're going to play this composition now. Then, coherence reduction is when the individual instruments start playing their different parts, maybe slightly out of sync, forming distinct melodies and rhythms. That perfect harmony, that undifferentiated sound, gets broken down. And what emerges? The distinct melodies, the rhythms, the harmonies, that's our observable musical reality. The phase conditions, those little theta symbols in the math we'll get to, they're literally falling out of perfect alignment. That's how the universe differentiates itself.
That clarifies it beautifully. Okay, and here's where it gets really, truly mind-bending for us as observers in this whole thing. In standard quantum mechanics, right, we talk about the observer collapsing the wave function. It feels kind of passive, almost accidental.
The measurement problem.
Exactly.
Yeah.
But coherence physics gives the observer a much more active role. It says the observer doesn't just collapse a state, they actively modulate coherence. Yeah. Which implies that different types of observation don't just pick one outcome. They can actually sustain, reduce, or even transform coherence. It's an active feedback loop. Our watching changes the coherence itself.
It puts the observer right back into the physics, but in a very different way.
And it's not just us conscious beings doing this modulating, right? The theory says this is universal.
That's a key point. It proposes this profound universality. Even things like inanimate fields or thermodynamic systems just cooling down. Even physical systems themselves act as universal observers. They're constantly performing this coherence selection.
So a crystal forming is selecting coherence.
In this view, yes. Or gas condensing. These aren't just passive physical changes. They're seen as systems actively engaging in coherent selection, stabilizing certain conditions, modulating that underlying field. It suggests this informational process, this modulation, is built into the fabric of interaction itself, everywhere.
Wow. Okay, so this raises an important question then. If coherence is this fundamental, how does it rewrite the basics? Things we thought we knew, like mass, energy, information.
It offers fresh and, pretty radical perspectives on all three.
Let's start with mass. You hinted this is a big departure.
It really is. Mass, in coherence physics, isn't some intrinsic property a particle just has, like a label it's born with.
Right.
Instead, it's redefined. Mass is a result of coherence gradients interacting with hypergravity.
Okay, coherence gradients interacting with hypergravity. Break that down.
Okay. Imagine that smooth, unified coherence field we talked about.
Yep, the perfect harmony.
Mass emerges from the wrinkles or slopes in that field. Those are the coherence gradients. The steeper the gradient, the more mass something appears to have.
So disturbances in the coherence field create mass.
Essentially, yes. And hypergravity isn't the gravity we feel day to day. It's proposed as the coherent foundation of all forces, a deeper, more unified gravitational field that interacts with these coherence gradients.
So mass isn't inherent, it's emergent, a consequence of how coherence is structured or broken down.
Exactly. It becomes a dynamic consequence, not a static tag. It depends on the coherence environment.
Okay, that's huge. So if mass is about these wrinkles, what about energy?
Energy gets a similar treatment. It's described as an expression of coherence potential.
The potential for?
The potential for things to emerge, to transform, to do something within this coherence framework. It's the inherent capacity for change within the coherence field, like the stored energy in that perfectly turned orchestra, the potential for that perfect resonance to break down into different melodies or transform in some way. It's the fuel for the universe's dynamics.
In information, we usually think of that as data, bits and bytes.
Here, it's much more fundamental. Information is conceptualized as the encoded structure of coherence determining system evolution.
Encoded structure.
Yeah, it's about the blueprint, how the coherence is organized, how those phases align, the amplitudes. That structure dictates how systems develop, interact, change over time. Information isn't just something we process. It's fundamental to how reality unfolds based on its coherent structure. It's like the universe's internal code.
Wow. Okay, so mass, energy, information, all redefined through coherence.
And these aren't just philosophical ideas. They're built on a rigorous mathematical framework, which I guess is where we need to go next to see how this all holds together.
Right? The math behind the magic. Okay, so we've got these big, ambitious conceptual shifts. Now let's dive into the mathematical scaffolding holding it all up. Any theory rewriting reality needs the math to back it up, right?
Absolutely. You need that rigorous language.
So let's start with the big one, the wave function of the universe in this theory.
Right. That would be the coherent state function, usually written as AC, psi sub c. And mathematically, it looks like AC equals the sum over I of c times e to the I times d.
Okay, sums and exponentials. What do the pieces mean conceptually?
Let's break it down. The C are the coherence amplitudes. Think of those as the strength or the intensity, maybe the probability amplitude, of a specific coherent state. Bigger C means that pattern is stronger or more dominant.
All right, strength and the theta.
Those theta are the phase conditions. And these are absolutely critical. They dictate the resonance, how well things are aligned, or the misalignment of these different coherent states.
So the phases are really key to the harmony or disharmony.
Exactly. Qualitatively, if all those theta phases line up perfectly, you get constructive resonance. That's your high coherent state, everything in sync, amplifying the unity.
Maximum harmony.
Right. But if the phases get misaligned, scattered, you get decoherence or symmetry reduction. That's the unified state breaking down into the separate things we observe. The phase function, theta, is basically the universe's rhythm section, determining if everything's in sync or playing its own tune.
So this eta C describes the state of coherence. But what governs how it changes? There must be rules, right? It can't just be random changes.
Precisely. These states aren't just happening randomly. They're governed by something called the coherence symmetry group, or CSG.
CSG.
Okay.
Now, if you're familiar with particle physics, you can think of this CSG as being analogous to Lie algebras in gauge theory.
Ah, okay. Like the symmetries of forces.
Kind of, yeah. In gauge theory, Lie algebras describe how particles transform while keeping the underlying structure the same. Here, the CSG's job is even more fundamental. Its generators, let's call them TAR, dictate exactly how coherence is preserved, how it transforms between states, or how it reduces. They're the basic algebraic rules for how coherence behaves everywhere.
And I see these structure constants mentioned. FabC, what do they do? Those FabC constants define the specific ways these transformations combine and interact. They're like the fundamental grammar rules for coherence changes. So the CSG provides the whole mathematical backbone for how reality unfolds from coherence, defining the symmetries and transformations of the coherence field itself. It's the rule book.
Okay, rule book established. Now, how does this math actually derive something like mass? You mentioned that equation earlier.
Right. Building on that framework, we get to the coherence mass equation. It looks deceptively simple. MC times GC, MCGC.
Lambda CGC. Okay.
Let's unpack those terms carefully. MC is the coherence wavelength. You can think of that as the characteristic size or spatial extent of a coherent state. How spread out or localized is this pattern?
Okay, its size.
And GC is the coherent symmetry coupling. That measures how strongly coherence interacts with or is connected to that coherent symmetry group we just talked about.
Yeah.
It's the strength of the coherence field's interaction.
Got it. So mass equals wavelength times coupling strength.
And the crucial insight, again, is that this directly links mass, not to some fixed intrinsic property, but dynamically to coherence breakdown and those coherence gradients.
So mass isn't fixed at all. It emerges from the breakdown.
Exactly. It emerges from the reduction of coherence, the loss of that perfect state, and from those wrinkles in the field. The more a system's coherence breaks down or the steeper its gradients, the more mass it effectively shows. It's a truly dynamic origin for mass.
Okay. And if that's how mass emerges, what's the actual mathematical engine driving this breakdown, taking us from that hypercoherent state to the structured stuff we see?
That would be the coherent reduction operator, usually written as R hat sub c. You can think of RS as the fundamental mechanism of the big emergence.
Mechanism itself.
Right. Its action is conceptually simple but physically huge. RS applied to HEO gives you AESE. What it does is transform a state of hypercoherence, that superunified, undifferentiated state, into structured interactions, into the pieces of our observable universe. It's the great differentiator.
How does it differentiate? What's its specific action?
The mechanism is that RC acts as a phase shift operator.
Back to the phases.
Exactly. So remember our state function,
Yes.
SGA. The operator changes it to reciprocate plus play. See that extra vo?
The delta theta, yeah.
That da is the coherence-breaking phase shift. It's a deviation from perfect phase alignment. The bigger that shift, the more coherence is lost, the more the harmony is disrupted, and the more structured, differentiated reality emerges from that initial hypercoherence.
It's like turning a knob that introduces specific deviations, sculpting reality out of the perfect state.
Precisely. It's sculpting reality through controlled phase shifts.
That's elegant.
Huh.
Now, in physics, we often use tensors to describe fields, like the electromagnetic field tensor. Does coherence physics have something similar for coherence itself?
It absolutely does, and this is where it directly locks horns with existing physics. It introduces the coherence field tensor, written as simunu. The definition looks a bit like the electromagnetic one. K'nera O plus GCO, let's break that down quickly. IO, is the coherence potential field, the fundamental field where coherence effects come from, like the EM4 potential. GC is the coherence coupling constant, how strongly it interacts.
So this Q tensor describes the coherence field itself, like its twists and turns in space-time.
Exactly. It's the map of the coherence field's dynamics and structure throughout spacetime. And its significance is immense because it's how the theory connects to and tries to redefine our understanding of fundamental fields.
And you mentioned it challenges general relativity directly. How?
This is probably the most audacious claim. Coherence physics states that this coherence field tensor, kin, actually replaces the Einstein curvature tensor in gravity.
Whoa, hold on. Replaces Einstein's tensor.
Yeah.
That's huge. Does that mean our whole understanding of space-time geometry is wrong or just reinterpreted?
It's a reinterpretation, yeah, but a really deep one. It implies a more fundamental cause. Instead of mass and energy being the source of space-time curvature,
Become manifestations or effects of coherence. The coherence field tensor tree describes how space-time geometry arises directly from the dynamics, the selection and reduction of that primary coherent state.
So the curvature we call gravity is actually an expression of the coherence field structure.
That's the idea. The geometry of space-time becomes more fluid, dynamically tied to coherence, rather than just being bent by mass, passively sitting there.
That is genuinely staggering. Okay, so finally, to make this a complete quantum theory, how does it handle quantizing coherence itself?
Good question. To be a full theory of reality, it has to embrace quantum mechanics. It does this by introducing quantized coherence. This involves defining a coherence field operator, A psi het C, similar to field operators for photons or electrons.
Okay, like a quantum field for coherence. Exactly. And along with that, you get coherence creation and annihilation operators, SACYO and SEC. These let you mathematically add or remove quanta of coherence from the field, just like creating or destroying particles. And there's a coherence number operator, NEC, to count these coherence quanta.
So you can count coherence packets.
In essence, yes. The ultimate expression is the quantized Hamiltonian for the coherence field, TACO plus 12. This is a standard quantum mechanical form, describing these coherence quanta oscillating, and it gives the energy levels for different states of coherence.
So it can be quantized.
That's the claim. This mathematical step is crucial because it shows the theory can potentially describe the universe at its most fundamental quantum level. It bridges the abstract idea of coherence to potentially observable, quantifiable effects. Coherence isn't just an idea, it's a quantifiable, energetic part of reality.
Right. Which leads us directly into its physical implications. All right, we've wrestled with the concepts, we've peeked under the hood at the math. Now let's get to the really exciting part. How does this radical new perspective actually reshape our understanding of reality? And let's start with something fundamental: mass. This theory seems to offer a totally reimagined view, going way beyond the Higgs mechanism.
And it really does. It's a complete rethink.
So first, the absolute core idea. Mass isn't intrinsic. It's a direct function of coherence laws. The principle is highly coherent states have lower mass. And the flip side, mass increases as coherence is reduced.
Right, it's dynamic.
Can you give an example? Like, how would that look?
Okay, picture a perfectly pristine, super tightly bound quantum state. Maybe electrons in a superconductor, perfectly synchronized. Minimal deviation, incredibly high coherence.
Got it.
Under this framework, that state would inherently have less mass than if it were, well, messier, less synchronized, less coherent. Mass isn't a fixed tag. It's a dynamic consequence of how much that perfect unity has been fragmented or diminished.
Like a perfectly tuned guitar string has less resistance than a loose, floppy one. The more broken it is, the more massive.
That's a decent analogy, yeah. The more coherence is reduced, the more inertia or mass it presents. It's not about having mass, but acquiring it through interaction with or reduction from the coherence field.
Okay, so what does this mean for the Higgs boson? The particle physics discovery hailed as explaining mass.
It means the Higgs mechanism, as we currently understand it in the Standard Model, is fundamentally replaced.
Replaced entirely.
That's the proposal. In the Standard Model, particles get mass by interacting with the Higgs field via spontaneous symmetry breaking. The Higgs boson is an excitation of that field.
Right.
Coherence physics says, hold on, you don't need a separate Higgs field doing that. Instead, mass emerges dynamically from those coherence interactions and gradients we talked about. It's a natural consequence of the universe differentiating itself through coherence reduction.
So the source of mass shifts from a specific particle field to the universal dynamics of coherence itself. And does this dynamic view explain the huge range of masses we see? The mass hierarchy? Why is the top quark crazy heavy, the electron super light, and neutrinos almost massless?
Yes, it offers a direct explanation. It links these mass differences to the coherence interaction strength of each particle. How strongly does a particle interact with or emerge from what the theory calls the coherence condensate field?
Okay.
Coherence.
Like a deep ocean of coherence.
Kind of. Particles that interact strongly with this ocean experiencing significant coherence reduction or steep gradients become heavy, like the top quark.
Right.
Those that maintain higher coherence or interact weakly with the field remain light, like the electron. And neutrinos. They're almost massless because they preserve a very high degree of coherence. They barely ripple that ocean.
That makes intuitive sense. But what about the actual Higgs particle signal they found at 125 GeV, the big discovery?
Yes. In this framework, that signal is reinterpreted. It's not seen as a fundamental particle giving mass directly.
So what is it?
It's understood as a coherence fluctuation mode. Think of it as an echo or a ripple within the coherence field itself, a specific resonance that pops up due to the dynamics of coherence, rather than being the fundamental mass giver.
It's like a sound the coherence field makes while it's working, not the thing doing the work.
That's a good way to think about it. It's an observable consequence, not the fundamental cause of mass in this view.
That's a really elegant reinterpretation. Okay, let's switch gears to another huge mystery.
Yeah.
Gravity. Binding galaxies, shaping the cosmos. How does coherence physics redefine that?
Gravity gets a similarly radical makeover. Its true nature is re-envisioned not as a fundamental force on its own, but as a coherence residual.
A residual, like leftovers.
Sort of. Remember hypergravity we mentioned earlier? That's supposed to be the coherent foundation of all forces, the primordial gravitational effect within the primary coherent state.
So the original unified gravity.
Right. Our observed gravity, the one Einstein described, is seen as a weakened remnant, a residual effect of this hypergravity.
And does that explain why gravity seems so incredibly weak compared to, say, electromagnetism?
That's exactly the explanation offered. Gravity seems weak because it results from its high coherence, which disperses across all dimensions. Because hypergravity is the most coherent of the emergent forces, its influence is spread out universally. It appears diluted and weak in our familiar four dimensions.
It's the least broken force.
Exactly. It's the least decohered, almost perfectly integrated, which makes its effects seem subtle compared to the more localized, broken forces.
Fascinating. Okay, so how does this translate into math? How does it integrate gravity?
It does so with a really revolutionary equation, Kuhn plus e to the gen h-10.
Okay, let's see. Kuhn is the coherence field tensor. Kuhn is Einstein's curvature tensor. Tune is stress energy.
Correct. And Huni is that coherence wavelength again. The crucial insight here is that this equation structurally means gravity is not a standalone force. It is a residual coherence effect. It's a byproduct. Space-time curvature itself is fundamentally governed by coherence.
Wow. Okay. But this raises a big question. If gravity is so highly coherent, why has it been such a nightmare to quantize, unifying it with quantum mechanics? What's the problem usually, and how does this theory fix it?
That's a great question, and it hits on why this approach is so different. The traditional problem with quantum gravity is trying to treat gravity like the other forces, quantizing it by imagining it's mediated by a force particle, the graviton.
Right, like photons for EM.
Exactly. But that leads to mathematical infinities and inconsistencies. If gravity is actually a residual, highly coherent effect, then trying to quantize it with discrete gravitons might be fundamentally the wrong approach.
What's the alternative here?
Coherence physics redefines the problem. It's not about quantizing a force, it's a coherence preservation problem. Gravity's quantum behavior isn't about gravitons popping in and out. It's about the nature of its own highly coherent eigenstate. Why does it retain so much coherence while other forces break down?
So understanding its quantum nature means understanding its coherence.
Precisely. It shifts the entire perspective on what quantum gravity is, potentially bypassing the traditional roadblocks.
That's a brilliant conceptual shift. And black holes, those ultimate gravitational beasts, singularities, information loss.
Black holes get a makeover too. They're re-envisioned not as mathematical points of infinite density singularities where physics just stops working, but as coherence collapse regions.
Coherence collapse.
Yeah. Regions where coherence has undergone such an extreme reduction that it creates a boundary, the event horizon. Beyond that, our usual understanding of space-time is dramatically altered because the coherent state is so different.
And the information paradox. Stuff falls in, information seems lost forever.
Crucially, in this view, information is not lost. Instead, it's proposed that information is stored within a coherence-preserved structure beyond the event horizon.
Stored?
Transformed into a state of hypercoherent storage, essentially encoded in the structure of the coherence field itself within that collapsed region. This offers a potential resolution to the paradox information isn't destroyed, just converted into a form inaccessible from our lower coherence perspective.
Okay, let's shift from the cosmic scale right down to the quantum realm. Coherence physics should obviously have a lot to say about quantum mechanics itself. How does it unveil QM's mysteries? Let's start with particles themselves, not random fluctuations.
Right. Instead of just popping out of random quantum fluctuations, which always felt a bit unsatisfying, a bit like magic particles emerge from coherence gradients.
From those wrinkles again.
Exactly. It suggests a more ordered, more deterministic process underneath. Think of specific ridges or valleys in the coherence field where the reduction is particularly steep. That's what gives rise to specific particles. It implies an inherent structure, a dynamic predictability rather than just pure chance.
The universe isn't rolling dice, it's sculpting particles from the coherence field.
That's the picture, yes.
Okay, what about entanglement? Einstein's spooky action at a distance. Still spooky.
Less spooky, perhaps more. Fundamental. Entanglement is explained here as a bivector coherence effect.
A bivector. Okay, what does that mean simply?
Think of a vector as pointing in a direction. A bivector describes an oriented plane or rotation. So a bivector coherence effect implies a deeper, non-local connection that isn't just 2 points correlating, but them being intrinsically linked through a shared oriented coherence structure.
Like they share a plane, not just a line.
Kind of. It means the entangled particles aren't really separate in the way we think. They're maintaining a shared higher-order coherent state across distance. It becomes a natural consequence of the underlying coherent structure, revealing a deeper connectivity woven into reality.
That feels more intuitive somehow. Okay, the other big quantum weirdness,
Right.
Wave function collapse. The superposition snapping into one reality upon measurement.
Wave function collapse, in this view, is not mysterious. It results from coherence decay. Simple as that. Yeah. The transition from the quantum world of possibilities to the classical world of definite outcomes is seen as a natural, dynamic process of coherence loss over time or through interaction. It's not an abrupt, unexplained collapse, but a gradual or rapid decay of the coherent superposition.
So the quantum to classical transition is just decoherence happening naturally.
Exactly.
Yeah.
And it's so integral that the Schrödinger equation itself gets modified. It becomes Ibris plus Fuss zero. That extra C-hat term represents coherence selection effects.
What does that term do?
It actively prevents purely random decoherence. It guides the transition, making it structured and coherence-driven. It implies the universe isn't just randomly losing coherence. There's an inherent feedback, a selection process, influencing how quantum states resolve into classical ones.
Wow, okay. Now, unifying the fundamental forces, the holy grail for physics. Standard model gets 3, but gravity's left out. Does coherence physics offer a path to bring them all together?
It absolutely does. It proposes the coherent standard model, CSM, and even grander, the grand unification of coherence, or CGUT.
CSM and CGUT.
Right. So the standard model's gauge group, that SU3, CSU2, Lev Y, describing the strong, weak, and electromagnetic forces, isn't seen as fundamental in itself.
Okay.
Instead, it emerges from a higher-order coherent symmetry group, CSG, the structure looks like, GC SU3 Lev U1Y SG.
A C infinity at the end.
What's that?
That C is absolutely key. It represents the ultimate universal coherence symmetry operator. All the forces we know are seen as coherence derived from this overarching symmetry through its selection and reduction. They're different manifestations of the one coherent reality.
So forces emerge from coherence breaking down in specific ways.
Precisely. And the CGUT aims to take it further, unifying all forces, including gravity, with their symmetries emerging dynamically from coherence selection. It provides a framework for potential unified groups like SU5 or SECR, or SO10SE, offering a coherence-driven origin for everything.
Is there a predicted energy scale where this CGUT unification happens? Like the traditional GUT scale? Yes, there's a predicted CGT scale. This is where all the gauge couplings and the coherence field coupling itself are expected to unify. The prediction is around HEGUT at 1016 to 1018 GeV.
Similar range to traditional GUTs.
Similar range, but crucially, it includes the coherence coupling itself. It's a truly comprehensive unification point where all interactions reveal themselves as facets of coherence.
Okay, so if it unifies forces, what about the universe's biggest mysteries? Dark matter and dark energy. They make up, what, 95% of the universe? Does coherence explain them too?
It claims to offer a compelling, unified explanation for both. Let's take dark matter first.
Yeah, the invisible stuff holding galaxies together. What is it?
It's proposed to be the leftover coherence state from CGT.
Leftover coherence, not particles.
Not exotic particles like WIMPs, no. It's seen as consisting of high SC remnant structures that were selected by coherence way back then, but simply did not decohere fully into standard model stuff. They kept a very high degree of coherence.
And that's why it's invisible and doesn't interact much.
Exactly. It remains invisible because it remains coherence selected, never fully transitioning into decohered matter states. This means it wouldn't scatter light or interact strongly, and crucially, it wouldn't scatter off detectors in the way WIMP searches are designed to look for.
So the fact that we haven't found WIMPs could actually be evidence for this.
Ironically, yes, the persistent null results in WIMP experiments could fit perfectly with this coherence-based explanation. It's not that dark matter isn't there, it's just behaving differently because it is coherence.
That's elegant. Okay, what about dark energy? The thing accelerating cosmic expansion.
Dark energy is identified as the large-scale effect of coherence loss, causing apparent accelerated expansion.
Coherence loss causes expansion. How?
It's not seen as a repulsive force pushing things apart. Instead, it's a symptom of the universe's overall coherence slowly dissipating over cosmic time and vast distances. As the underlying coherence weakens or becomes less resonant on the largest scales, this gradual loss manifests as the accelerated expansion we observe.
So the expansion is driven by the universe losing its overall harmony.
That's the idea. It provides an intrinsic, coherence-driven reason for expansion, linking it to the universe's fundamental energetic state rather than needing some mysterious extra energy field.
Wow. This theory really is trying to connect everything. Does it go all the way from cosmology down to life and consciousness?
It absolutely does. Its reach aims to span all scales. In cosmology, the Big Emergence framework replaces the Big Bang idea, framing cosmic evolution as a continuous series of coherence reductions from that initial hypercoherent state.
A big emergence, not a big bang.
Right. And crucially, space-time itself is a coherence-selected construct. Not a fixed background, but dynamically emerging from coherence. Our 4D spacetime is just one stable configuration.
And scars.
Stars like our sun are redefined as coherence reduction engines. They convert coherence into energy. Stellar output is seen as a coherence phase transition, not just a nuclear process, though nuclear reactions are part of it. Even nucleosynthesis, element creation, is coherence-driven, with coherence affecting reaction rates.
You mentioned quantum computing earlier.
Yes, huge potential implications there. Imagine a coherence-based quantum circuit that could process information without decoherence. The theory suggests coherence selection could be used to sustain quantum superpositions indefinitely. This leads to the idea of a stable coherence qubit, or C-qubit, potentially overcoming the biggest hurdle in QC.
A stable qubit. That would be revolutionary.
Absolutely. And then, perhaps most profoundly, it touches on life and consciousness.
How?
It suggests biological systems function as coherence engines, actively restoring quantum coherence in a self-organizing way. Consciousness itself is a coherence process, where the brain sustains highly ordered, complex coherent states. Ultimately, life and intelligence emerge as a self-organizing coherence process, perhaps stabilizing early chemistry and driving complexity. It paints this picture where everything, particles, stars, space-time, minds, all emerge from this single principle. Coherence.
You'd think that covers everything, but no, it goes even deeper. It culminates in this universal coherence dynamics framework, UCD, aiming to be the most comprehensive description yet.
Exactly. UCD tries to tie it all together into one unified mathematical structure. Its core is the UCD Lagrangian. LUCD equals L gauge plus L gravity plus L coherence plus interaction.
Okay, Lagrangians. The master equations in physics. This one puts coherence right in the middle.
Right in the middle. It formally places coherence at the heart of all interactions, gauge forces, gravity, how they interplay. The key idea is that forces, mass, space-time itself emerge dynamically from these coherence interactions. They're constantly being shaped, selected, refined by the evolving coherence field. Reality as a dynamic unfolding.
And it even redefines time.
In a truly radical way. UCD proposes time isn't external, just ticking along. It's an emergent property of evolving coherent states. The equation de Lakidze suggests time flow is linked to coherence decay. Care is coherence wavelength. Ron sees a decay rate.
So past, present, future are just different coherent states.
That's the implication. Time becomes woven into the fabric of how coherence unfolds, not just a background parameter.
Mind blown. Okay, let's unpack this further. Unified chromodynamics, UCD, QCD, reimagining the strong force, the one holding atomic nuclei together. How does it redefine quarks and gluons?
So quarks and gluons, the building blocks in standard QCD, aren't just predefined particles here. They emerge as coherence eigenstates.
Eigenstates of coherence.
Meaning their very identity, their properties are tied to specific stable coherent patterns in the field. Even color charge, that weird property of quarks, isn't seen as intrinsic. It's a coherence-selected property arising from the underlying coherent structure and its symmetries. Like different colors or different ways the local coherence field can manifest.
In this coherence view, does it explain those weird strong force behaviors? Confinement quarks always stuck together, and asymptotic freedom, they act free at high energy.
It offers a really elegant explanation. They're seen as coherence phase transitions.
These transitions again.
Yeah. At very high energy, short distances quarks are effectively free. Asymptotic freedom. The coherence field is strong and unified, minimal binding, but as coherence reduces lower energy, larger distances, they become strongly bound. Confinement. The force strength itself emerges from the degree of coherence breakdown.
A unified explanation for a long-standing puzzle. Nice. What about the three generations mystery? Why three copies of quarks and leptons? Does UCD, QCD explain that?
Yes, and this is a potentially powerful piece of explanatory power. It proposes an explanation via S3 reduction.
S3, like a symmetry group.
Exactly. It's a specific coherence-driven symmetry breaking pattern. It starts from that ultimate Cia coherent symmetry, breaks down to this S3 permutation symmetry group, and then breaks further into the standard model groups. That specific S3 pattern naturally leads to exactly 3 generations.
Wow.
And crucially, the mass hierarchy within those generations, why the top quark is way heavier than the up quark, etc., is seen as a direct function of the specific coherence conditions and reduction paths for each generation. The 3 generations aren't arbitrary. They're linked to how coherence systematically differentiates itself.
That feels less arbitrary than just saying there are 3. Okay, now this hyperfractal manifold idea, challenging space-time itself, not 4D.
What's fascinating here is, it challenges the view of space-time as just a fixed 4D stage. It proposes dimensions themselves emerge as fractal coherence layers through coherence reduction.
Fractal layers.
The equation is DC Ailey, where DC is the effective dimensionality. High coherence means potentially much higher dimensionality, many fractal layers. As coherence reduces, those higher dimensions sort of collapse or coalesce, leaving us with our observable 4D reality.
So the other dimensions are there, just in a higher coherence state?
Effectively, yes. Or our reality is a lower coherence slice of a higher dimensional fractal structure. And within this fractal, force localization happens naturally. Gauge fields, electromagnetism, strong force are confined to specific fractal layers. They operate within different dimensional strata, which is why they seem localized and have different strengths. But gravity, it remains hypercoherent across the full fractal.
Explaining its weakness and pervasiveness again.
Exactly. It spreads its influence across all dimensions. The ultimate math uses a hyperfractal Lagrangian, incorporating this geometry, where coherence modifies everything, even derivatives. Space-time as a living, evolving fractal entity shaped by coherence.
Okay, here's where it gets really interesting for chemistry and life. It extends to cosmic chemistry, planet formation. How does coherence drive that, starting with nucleosynthesis element creation?
Right. It's not just about temperature anymore. Element formation, fusion in stars, the R process, PES process, is seen as a coherent selected process.
Coherence helps fusion.
It enhances fusion rates, determines element stability. Specific coherence conditions might create sweet spots for reactions, influencing the abundances we see. It adds another control knob to cosmic alchemy.
And out in cold interstellar space, making molecules.
Interstellar chemistry, molecular cloud formation, even making complex organic molecules also coherence-driven. Coherence fields can guide reaction pathways, stabilize intermediates leading to stable, complex molecules, maybe even life's precursors where you might not expect them based on temperature alone.
It suggests life's building blocks aren't just random chance.
Exactly. Guided by coherence, and this goes right down to planets.
How does coherence help build a planet? Dust sticking together seems hard.
Planetary accretion, dust clumping into planets, is coherence-assisted. Those coherence fields enhance the stickiness of dust grains, helping them overcome bouncing off each other or breaking apart. It makes planet formation potentially more robust, guiding the aggregation.
But even after a planet forms,
Even things like atmospheric retention, or why planets differentiate into core, mantle, crust, these are also framed as coherence-selected processes, not just about gravity. Coherence dynamics could influence gas binding energies or material phase transitions, guiding how planets structure themselves. It connects the quantum coherence level right up to planetary science.
it's truly astounding the breadth of this. But you said it goes even deeper, into mathematics itself.
Indeed. Now we get to what coherence physics considers the absolute bedrock, the very seed, the mathematical expression 0, 0, 0 equals 1.
Okay, I remember that from math class.
Yeah.
Often called undefined or context-dependent.
Exactly. It's controversial in standard math. But in coherence ontology, it's not just a definition. It's elevated to the coherent seed, the primal seed of emergence.
Yeah.
This single axiom is claimed to encode the jump from nothingness to structured reality.
0 to the power of 0 equals 1.
The interpretation is emptiness, 0, raised to itself, generates unity, 1. It's the first discrete step. The moment pure potential reflects on itself and produces the first definite thing, 1. This is supposedly where all mathematical and then all physical reality begins.
That's a poetic origin story for everything.
Yeah.
So what does this mean for nothingness? It's not empty.
Precisely. Nothingness isn't a void. It's redefined as a latent state of perfect coherence, pure, undifferentiated potential. The ultimate zero state from which all ones, all specific realities can emerge.
And mathematics itself comes from this.
Mathematics emerges as the structured expression of coherence transitions. Numbers, operations, geometry, they are the language describing how coherence differentiates and transforms itself. And physics arises when this mathematical coherence undergoes symmetry reduction, moving from abstract perfection to the interacting world we see.
So the universe is math, brought alive by coherence reduction.
That's the core idea, blurring the lines between abstract thought and physical existence.
And this coherence view changes even basic math,
Yeah.
like adding.
Even arithmetic gets reconceptualized as coherence-weighted. Addition might be described by something like AC, AB, EC plus B, implying the result depends on the coherence context. So numbers, sets, algebra, topology, they're all coherence-selected entities or transformations, not absolute pre-existing truths. They're dynamic expressions of coherence.
And Gödel's incompleteness theorems, those limits on math.
Intriguingly, they're reinterpreted as holding only in incoherent systems. The suggestion is that within a truly coherent unified system, those logical limitations might be overcome or just not apply in the same way. A potential path beyond inherent logical paradoxes, perhaps.
Okay, here's where it gets really interesting for me. Connecting abstract math back to the physical universe we live in, how does that happen?
It's described as a coherence phase transition.
A phase transition from math to physics.
Exactly. Physical laws don't just appear. They emerge when mathematical structures undergo coherence activation or reduction. Our physical universe is seen as a lower coherence subset of a vast underlying mathematical structure. The specific laws we observe, gravity, EM, are just the stable coherent states selected and maintained within that mathematical reality. Physics literally emerges from math via coherence.
It's elegant, I'll give it that. But a theory, this ambitious redefining reality from math up, It must have testable predictions, right? It can't just be philosophy.
Absolutely, it has to make contact with experiment. And coherence physics does propose specific testable predictions.
Okay, let's unpack those. Where would we look? Okay, let's get concrete. If coherence physics is right, what should we actually see changing? You mentioned mass.
Right, a key prediction. Mass should change in coherence-altered environments.
Like where?
Think extreme cold, near absolute zero, where quantum coherence is naturally higher. Or potentially in lab-created high-coherence fields. Measuring a particle's mass and seeing it change based on its coherence environment would be huge.
A direct test. What else related to mass?
Instead of just one Higgs boson, the theory predicts multiple mass states should exist, reflecting different coherence resonances or reduction pathways, a richer spectrum related to mass generation.
So not just the 125 GeV signal.
Maybe others, or maybe that signal itself has a substructure linked to coherence. Also, it predicts small but measurable shifts in MW and MZ, the masses of the W and Z bosons, compared to standard model predictions due to this different mass generation mechanism.
Okay, subtle shifts in known particles. How would we test these?
High-precision mass spectrometry is key, especially under unusual conditions. And future high-energy colliders would be crucial for looking for those multiple mass states or precise deviations in W and Z masses.
This raises an important question then. What about gravity and dark matter predictions? Big puzzles.
For gravity, since it's a residual coherence effect, it predicts deviations in black hole merger signals from LIGO-Virgo data. The exact shape of those gravitational waves should differ slightly from pure general relativity predictions, hinting at the underlying coherence dynamics.
Subtle differences in the chirp.
Potentially, yes. Also, it predicts modified galaxy rotation curves without needing dark matter halos. The rotation anomalies might be explained by coherence effects altering gravity on galactic scales, possibly via that hypergravity concept.
Explaining rotation curves without dark matter.
Yeah.
That would overturn cosmology.
It would be revolutionary. And linked to that, for dark matter itself, the prediction is a continued lack of WIMP-like detection.
Because it's not WIMPs.
Right. Because coherence-based dark matter is a leftover coherent state, it doesn't scatter like WIMPs are expected to. So the ongoing null results from direct detection experiments become, in a way, supporting evidence.
How to test.
Continued gravitational wave observations with increasing sensitivity, detailed cosmological surveys mapping galaxy dynamics, and of course, carefully analyzing the results, or lack thereof, from WIMP searches.
Okay. What about predictions in the quantum realm itself, or for nuclear synthesis?
In quantum experiments, we should look for deviations in quantum entanglement persistence. Maybe entanglement lasts longer under certain coherence conditions or decays differently than standard QM predicts, even more exciting. New behaviors in coherence-engineered quantum computing circuits. Can we build QCs based on this theory that outperform standard ones by actively manipulating coherence?
Using coherence to stabilize qubits.
Exactly. And for nucleosynthesis, the theory predicts coherence corrections to fusion rates and elemental abundances in stars and the early universe. Coherence playing a direct, calculable role in element formation.
Detectable differences in star composition, or the CMB.
Potentially small, but yes. Testing requires cutting-edge QC experiments, plus highly precise astrophysical observations, stellar spectra, CMB analysis looking for those subtle coherence fingerprints.
Finally, does it predict any entirely new particles we haven't seen?
Yes, it predicts that beyond standard model, BSM bosons should exist as coherence-induced gauge states.
Bosons related to coherence itself.
Exactly. They wouldn't be random new particles. They'd be mediators of coherence transitions, directly linked to the coherence field's dynamics and symmetry breaking. Concrete targets for searches.
Where would we look?
High-energy colliders again, LHC, future colliders. Searching for specific signatures or decay products unique to these coherence bosons. Finding them, with properties matching the theory, would be monumental validation.
Wow. What an absolutely incredible journey we've taken today. A true deep dive into the core of coherence physics. We've gone from its fundamental axioms redefining reality through the math, to how it revolutionizes mass, gravity, quantum mechanics, cosmology, even consciousness and math itself.
It's breathtakingly comprehensive in its scope.
It really is. We've seen how it offers this unified hierarchical story for, well, everything, suggesting a universe that dynamically emerges from this single principle of coherence. A universe that isn't just governed by laws, but is an unfolding coherent process. So, reflecting on all this, what does it mean for us, personally? If reality is fundamentally about coherence, selecting it, reducing it, preserving it. What does that imply for how we perceive and interact with the world? Are we? Are we all just local coherence modulators, actively shaping our own little patch of reality through the coherence we maintain, the focus we choose, the connections we build?
It certainly invites that kind of reflection. It shifts the perspective from passive observer to active participant in the cosmic coherence dance.
It's a really profound thought. It asks us to reconsider our place, not just watching, but maybe co-creating within this coherent cosmos.
And beyond the personal, think about the scientific frontiers it opens up. Could we, as you mentioned, actually engineer conditions to reproduce CGUT transitions in a lab someday? Glimpse that unified creation state.
Imagine that.
Or are there subtle coherence remnants, maybe patterns hidden in the cosmic microwave background, that tell the story of the very first stages of the big emergence, waiting for the right instruments, the right analysis?
The potential for discovery seems immense.
Absolutely. The questions are inspiring. It invites us to look at the universe and ourselves with completely new eyes. There's always more to learn, more to question, more to explore.
We really encourage you to ponder these possibilities, maybe look into it further.
Definitely.
Thank you so much for joining us on this deep dive into the possibly coherent fabric of reality.